So first we'll see like why Unix, right? And this is a very basic question, and you should have a good understanding. And one of the strong, and we'll go with the Unix file structure. That is the strength of the Unix. And there are tons of, well, actually not there are tons. There are only 20, 30 commands in basic commands in Unix, not that many. Everything is a combination of those. But we'll go into detail into one. The reason is like once you go into detail into one, you'll have some understanding. Maybe you can go 1 to 5. I'm going to skip the 6, and then we can move to the next lecture. So this is a computational biology workshop. The idea of computational biology is like you input some data, and then you have something goes inside, which we call a pipeline, and then you get an output. Okay, so that's basically, a lot of you have done genomics, so you input your raw data. At the end, you probably get a VCF file or something. So that's called a pipeline, right? So it's almost like, yeah, you came with the data, and there is a secretary who says like, okay, you have this data, so go to that person. They talk to each other, and then finally they give you an output. Okay, so Unix makes it the programs in Unix and programs in like the commands, they are so flexible that they makes it very easy to create these pipelines. So you can think of Unix as like a workbench. You have all these different tools, and each one of them does only one job, but they do so well, like they're the top at their class to do that job. And then you can combine them to make your pipeline. And that's why we computational biologists do Unix. The difference between a Windows thing is in the sense like a program in Windows can do few things very well. So you buy a program, this program can do this, and so on. They can do very well. But now if you want to change something to, you all are researcher, going to be researcher. If you want to change something, it's not easy to change in Windows. Okay. And that's where the Unix is easier to change, because in Unix, everything is just combined together. You can change a part. Okay. So, and that's why in computational biology, we use Unix, because we want those very specialized tools, and we want to combine them to make a pipeline just for us. We don't want to rely on those prepackaged pipeline. We don't want to rely on those commercial pipeline and so on. So the first stage of Unix is like understanding the file structure. So Unix has a very definite file structure, no matter which flavor of Unix you use, Ubuntu or Mint or Red Hat or whatever you use. The file structure is uniquely defined, and that's a strength compared to Windows. And I'm calling Windows because Mac is basically a Unix based OS operating system. They put their wrapper on it, GUI on it, but underlying it's Unix. So Mac has a similar file structure. So what is in the file structure? Okay, if you have your own Unix laptop, you can check it. We'll go to the OSC, we'll check all the file structures are same. You have something at the top called root file structure, and that's just a slash. Okay, under the root file structure, you have called binary bin. That means like binary means all the programs that stay there. So, and we'll come back later why the binary has a separate, all the programs has to stay in binary, and there is another similar directory. Okay, then you have devices. Devices means like your mouse, your monitor, all those drivers, and you have etc. That's an additional like password file and so on. And then you have home. Under the home, you have the users. Okay, so anytime you log in, you are going to end up, you are going to direct it to your home/user, like whatever your username is. That's where you're going to, as soon as you log in, you're going to come back here. But there are, and then inside the your user, then you can, it's up to you what kind of directory you make, what kind of file you make, and so on. But one of the file, there's typically stays everywhere. It's called .profile file, and we'll go a little bit in detail because that file is very important. Sometimes some system has .bashrc, .cshrc, but typically it's a .profile file, and we'll go into a little bit details. Then you have the libraries and the mount, like if there is a hard drive mount, and so on. The one of the interesting part is there is an user directory under which there is another binary directory. So there is a difference between a binary directory and user/binary directory. The difference is anytime, and this is like if your system administration is good, like, yeah, you are not supposed to install program in the binary directory other than the the programs that came with the Unix or certain programs that needs to there. If you want to install a program, that's where your program should be, your binary should be. Binary means like executable in the sense like you just give the command of the program and it's going to run. Okay, like ls. Ls is we are going to do ls. Ultimately these are all scripts. If we get the time, we'll write a short small script. Ultimately these are all script, but they're put together in a format, executable format, and that you just write, and it works. It does your own job. And probably during the workshop you'll write some of your own binary scripts. So the structure is really well defined. It's not like Windows. Your user is like buried under 10 different directories, and it's very hard to know which part is what. So it's a very well defined structure. So very easy to find where the files are. So that's the first benefit of Unix. The second is it's a very hierarchical in the sense that depending on what kind of system, if you are in a cluster, you only may have access to your directory. You may not have access to another directory. Okay, so the permission base is very strong, and that helps. That's why the securities in the Unix system are way stronger. That's because you cannot just go and save something under the binary directory. It's just not going to happen. Your permission is only here. Okay, and that's probably another user. And if that user does not give you permission, you cannot go into that person's directory either. So very well-defined directory structure and very well-controlled permission. Okay, those are the two strong points of Unix. We went through some of these. That's okay. Okay, so now what we are going to do is like we are going to get out of the. Let's see if I want to. Yeah, we are going to open a terminal. Now, not everybody has a terminal. A terminal means where something you can put the command line. So if you have your own Linux system, go ahead, open a terminal. If you do not have a Linux system, let's go to the, let me log out here so that I can, so now you can practice with me. We are going to practice it together. So let's go to OSC, well, no, ondemand.osc.edu. So you all should have, I didn't do something right. Okay, you all should have, and I'm going to increase the font a little bit so that you can see better. Okay, you all should have account there. So let's go ahead and log in here. I'm going to take a 30 seconds break so that you can all log in here, okay? So if you logged in here, let's see. Now I have to remember how to open a console here. If any one of you remember, okay, here we are supposed to use the ON one. So let's go ON shell access. Okay, so that's a terminal. So either you go to OSC ondemand.osc.edu, or you open a terminal at your own laptop if your computer has Linux based. Okay, so let's go. Let's do that. Okay, so while you are doing it, I have put these two files in the course materials of the Slack that I would like you to download. There are two zip files, and inside those zip files, let's see, what do we have? Okay, so we are going to look into Unix 1. So there are two files, one and what we are going to do is like we're going to transfer this 1 and 2.sh file to OSC on demand. Okay, so and these are small files, so it's not going to take too long. So let's see. So first, let me see if there is anything in my directory. Nothing. And files. Do any of you remember how to transfer files here? Let's see, home directory. I think we can drag and drop here. There you go, upload. So if we go files to home directory, if we do upload, we can drag. So what we are, I'm going to drag the two sh files here. Okay, and upload to files. Okay, and if I come back here, I have two files. Okay, so let me know if all of you are with me. All of you either have downloaded those zip files, transferred those two .sh files either to your laptop certain directory or to OSC. And I'm going to give you guys a minute, and if you need more time, just let me know.
Just uploaded the files.
Okay, thank you. Okay, well, does anyone need a little bit more time? Okay, I'm going to, if nobody speaks up, I'm going to assume all of you are able to transfer the files. Okay. So these files, the files that you transfer to OSC, to see a file in a Unix command line base, we usually use editor. There are multiple editors I use called VI, and these are not easy if you're using for the first time. These are not easy editor to learn. Okay, so it takes a little bit time, and we are not going to learn that today. So, but just to give you an example, like, well, it's just only showing me half of the file. Oh, the color is different. Anyway, so that's, we do it in the VI, okay? But because this file is in your computer, you can open it with something like Notepad or TextEdit or Gedit, whatever, something like simple. Don't open it with Word or something. Okay, so I want you to open it with, I used it Notepad, and and we are going to follow these files. And I'll explain a little bit. And a lot of you already know some of it. However, It's still good to demystify what Unix means. Okay, so number one is a script file always start with the first line. It's called shebang. And what does it mean? What does it mean? You see, like in Unix, there is a forward slash, and that means a directory. Okay, that's how the directories are. So it's saying like whatever in this file I have, I am writing in certain language, but how the computer is going to translate that. So I'm telling the computer like, whatever I'm writing here, you need to translate that through the command, through a program called bash. And that program exists in the binary command. So that's called shebang, and shebang has a history. It's a very, very odd history that came into the Unix in the sense like it came from prisons in USA wherever the shebang used to be a potato chips company, and they used to start their meeting by having the shebang potato chips. So it starts before anything, and that's the word just kept the Unix users decided to keep. So it's basically something that counts before everything. Okay, so let's see if that program. So I'm asking like, okay, whatever I'm telling, later part of the file, you need to translate it through that bash. So let me, and I'm jumping ahead a little bit. Let's see if they do have bash. And there's a lots of file, and don't worry, we'll go through it again slowly. Just making sure they have the bash. Okay, so they do have bash. So I'm just asking like, okay, in this file, I'm giving you some command and you have to translate it through bash. Okay, okay, that's fine. So next is, and this is I want you to follow. Anytime after, other than the first line, anytime you put this ampersand, whatever this sign, hashtag sign in the front, that means it's a comment. It's a comment. The program is not going to translate it. If you want to be a good computational biologist, you have to write a lot of information over your file, because you are going to write so many scripts that you'll forget yourself. Like, oh, why did I write that? Okay. And then, you want to pass that script to your friends and collaborators, then they will have an even harder, difficult times. So that's why, even if you write a 3-line code, it's okay to write a 10-line description so that you can come back and you look at it and say like, that's why I wrote it. So typically what I do is like, okay, who is the author? What is the purpose? When it is created? What is the last modification? How do you use it? And so on. A lot of the materials were taken from the Unix and Perl Primer for Biology. It's a very good book. So if you want to learn it later on your own time, I recommend this book. Okay, so and then whatever we are doing, we can run all this program by a single, because it's a script, but we are going to go through one by one line. So the first here, I want to point out something. Anything that ends with sh, like not anything, like this sh means like shell. Shell means like the basic programs that the Unix can run. And there are different kind of shell. So bash is one of the basic shells, and there is like C shell, which is like a C programming, CSH. Then there is a TC shell, like so again ending with sh. Then there is something Z shell, and so on. So this commands that is ending with shell, that means like those are the basic programs that Unix use to to interpret a program that we write. Okay, so and typically your computer will come with most of this shell programming. So let's see. I think like the program that I want to first try is, and again, you can follow that file. You don't have to follow with me, but I'm going to follow these. I'm going to go through it. The program that I want to try first is ls. Ls, Unix programs are 2 to 4 letters. Typically, it's a short for the English. Ls means list. And what it does is give you the list of the files in your directory. Okay. And then another important one is like PWD, which means print working directory. Okay. So what it does is like it prints what is your current directory. So right now I'm in my current directory right here, users, and this is something like home and then my username. Okay. If you are working on your directory, your computer will be slightly different. Okay. And then if I want to go, if I want to go like the root directory, let me see if it allows me to go. So I'm at the root directory right now. The first directory, if you remember the structure, the first directory had a /. If I look at here, now you can see all the file structures that I was telling. There's a binary directory. Well, the binary files are there. There is something on the user. There should be another binary directory under the user. Let's go. So, well, ls user. So yeah, so under there is a binary directory under user. So this is your file structure, okay? And you should be under either home or users. In your computer, you should be under the home because it's a cluster, you're under the users. So now, if I want to, okay, so CD, I probably already used the CD. CD means change directory. So before I use the command CD to go to the root directory. But if I just type CD, well, let me first do PWD. So I'm at the root directory. Print current working directory, I'm at the root directory. Now, if I just put CD, it's going to take me to my home directory. Okay. So anytime from anywhere you type CD, you are going to come back to your home directory. Okay. But if you want to go somewhere else, you have to give the path. If I want to go to, let's say, CD under the root directory, I want to go user. Then under the user directory, I want to go to binary, I have to give the path. So so I have user/binary directory. Again, if I print CD, I'll be coming back to my home directory. Now, instead of absolute values of the directory, you can give a relative values. What does it mean? So let's see, if I am currently under user/pgs0299 and so on, right? I want to go to this directory, right? So I can give the command cd/user/pgs0299. And I am in this directory. Okay, let me come back to my home directory. But I don't want to type the whole thing. So there's a way to relatively doing it. Relatively means a dot means current directory. Okay, and dot means right here. 2 dots means like 1 directory up. Another 2 dots mean 2 directories up. Another 2 dots mean 3 directories up, and so on. So this is the relative. So you can go up. Okay, so let's see if I go 1 directory up. So I am right here now. Okay, so there is 2 ways to move between the directories. One is to give the absolute path or the relative path. So a single dot means this directory, 2 dots and / mean the directory above, and then in so on and so on. Okay, and again, I can come back to my current directory, change directory. If I just put CD, anytime you put CD, you are going to come back to your directory. Okay, so that's like the quick way of the file structure. And I'm going a little bit faster then I typically go because it seems like most of you have done a little bit of ls and so on. Okay. Any question? Okay. No, move forward. Everybody understood everything. Next is the dirty secret of how we do it. I don't remember all the options of a Linux. The way to, but as I tell, like a single program in Linux or Unix, they are so versatile. They have so many options. It's impossible to remember everything. You only remember a few of those. So how do you find all this information? One is Google. You can always Google. I mean, like, and somebody has written that. The other is typically if a programmer is sincere, they write a manual for the program. And the manual, to get a manual for the program, the command is man, that means for the manual, and then the program name, ls. Okay, so we are going to look at the manual for the ls, let's see. And this is the structure of a manual file. So we'll go slowly because there will be a lot of the time where you are writing a new program. You want to understand all all the options each of the tools can give you. Okay, so man is the way to go it, and also there's Google, but man is the complete way to do it. Okay, so and all of the structure in the man are very is similar. First is it will give you the ls, the name of the in this case the name of the program, and what does it do? A description, list, directory, contents. Well, let's see. Somebody is not muted. Let's see. If you do not have to ask a question, can you please mute yourself? I encourage you to ask questions. But if you are not asking questions, please mute. And then the synopsis mean how do you use that program? Okay. So the program, anything under these square brackets, those are optional. That means like you do not have to write those options. The program will still do its job. So in this case, ls, whatever comes after that, anything under the, everything is under the square bracket. So that means like you can run the program just by typing ls. That's it. And we'll look into another one where, that's not possible. And then the options are what makes a program versatile. And the options are given here. And next is the option. So you have the synopsis that tells you like how to use that program. And next are the options, either -a or dash dash all. Do not ignore entries with dot. And we'll look into that sometime. Unix starts certain file name with a dot to hide those files from common view. And -a forces them to list, and we'll just check that one. So any program or any tool, Unix tool, should have a manual page. Sometimes people write tools without manual, and that's unfortunate. But a proper tool should have a manual page, and they should have this a structure. And from this structure, you understand all the different options. Now, when I type man, it shows me one page at a time. So it is showing the first page. If I click the space bar, it's going to show me the next page. So you can see like how many different options the ls has. The ls you probably used like 100 times in your life, but it is such a versatile program, and that's like the benefit of Unix. Like each program is so versatile that you can use it in so many different ways. So we can keep going. This is the third page, fourth, and so on. And if you want to get out of it, the man page, just hit Q, and you'll get out of it. Okay. So the manual page will give you an idea how rich each Unix tools are. And as you become more and more efficient in programming, you are going to start using those different options to make your pipeline rich and versatile. So we looked into ls, where you saw ls, and then there are square brackets. That means like we don't have to give an option. But let's look at another command called let's put mkdir, make directory. Okay, and that makes a directory. Okay, so let's look at the manual of mkdir. So here, mkdir, make a directory. In the synopsis, you can see mkdir square bracket options, but then there is a directory that does not have a square bracket. So that means like you have to put a value for this one. It does not have a square bracket. Okay. So, and we'll try without giving any option here, and you'll see that the program will say like, nope, I'm not going to run it. So just get used to reading the manual pages. And this is this is what you are looking for. There are some options there. They want some values here. I don't have to give it a value, and so on. Okay. So let's just write mkdir, and it says like, nope, something is missing. I cannot do anything. The reason being is like it is expecting a value as per, it was written very clearly in the manual. It's expecting a value. Okay. So that's a little short example of how to navigate different commands. Again, there are only like 10 basic commands in Unix. And when I say basic, means like those are written in like really low-level language. 10 or 12, I don't know. It's a very small number of Unix commands. Anything else is a combination of those 10, 12 commands. And they are written as a script, and then they have been like put as a script and put on the binary directory. And then, of course, people make their own script. Okay, so let's see. And then we are going to jump into a different strength of Unix. And before that, am I going too fast? You have any question, any suggestion? Let me know. How are you being able to follow me?
Yes, sir, we are being able to.
Okay. Any other comment, question?
A quick thing I want to mention a little bit. There is another option for most of the programs that is called help, or option H, that actually prints some of the basic options very quickly. If you don't have much time, you just want to
Help
I don't
LS?
think. No. Actually, maybe.
Yeah, those are.
types-
Let's see.
Yeah.
Those probably the second level programs that.
Yes. 7
Yeah.
level for second level programs.
Yeah, those are not. I do not know if the basic programs has a -H option. Let's try another one. Yeah, it does not, or like. Yeah, no, it's basically, as I said, there are only 10, 12 basic programs like move, temp, mkdir, ls, and then you other programs are based on, is a combination of those, and those may have a -H option, because when you're writing the
it's not for all programs, but mostly a few second level program that you have a -H or a double option help that will show the quick commands that can used mostly used commands to options.
Okay, good. So is it okay if I move to the second hands-on? Because let me show you what was the part I cover is like some of the different commands, but seems like most of you has some experience with these. So these are the typical commands that you have to use every day. ls, we already use, change directory, manual we used. Uh, copy, move, and remove are some of the other programs that you use a lot. And then maybe the less, we can look into less. But what I want to, I don't want to go in these because these, if anytime you need a little bit of help, like how do I do this? You just Google search, and then the Google search will give you, they're getting so better, they'll give you the Unix command to do certain things. Okay, so that's why I don't, you don't have to memorize. I don't memorize. Anytime I forget or something, I just do Google search, and I encourage you to do the same. Okay, less is a quick way of reading a file. So let's say if I type, let's say what files do I have? If I type less webinar 1.sh, is going to give me, what's in the file. And again, it's going to give me one page at a time. You can put the space bar to see more and so on. Okay, and I think if you can, Q is going to give you out. So less is another way of looking into a file. What I want to move on to next is another powerful option called alias. And you probably will be use alias a lot if you're using Unix often. Okay, and we'll come to that portion of why we need to use alias. Okay, and that portion is described. Let me see. Let me open with. Okay, so that is actually not part of the first lecture. That's part of the second lecture, but that's okay. So it should be in your Unix 2 directory. Let me look into the. Yeah, it's if you go to the Unix 2 and let's see, and if you open the file, no, that's not the file. File for organize. Well, I may not have a file for this, but that's okay. We are going to run with it. Okay, so in Unix, there is another powerful thing, and I talked a little bit about that profile file, and then alias will show an example of why the profile file is needed with the command called alias. Okay, and we'll get to that now. Okay, so again, the files that I provided, they are self-guided, and you feel free to go through it at your own time. But today, I just want to highlight some of the points of the Unix. So we played with the ls, right? Now, if I do just ls, it gives me, let me move this one here. It gives me the directories. It gives me the file names. Now let's do ls, and these are some of the options you don't have to remember. It's just I use it all the time. I remember, and but we'll explain it. So I want more information about the files. Okay, so a long version, -l, give me a long version. So in a long version, what it gives me is like, okay, well, here is the file name when it was created. What is the file size? Which directory? And then we will come to this. We'll come to this because that's a very important part. Okay. But one thing that I don't like is like the size is given into what is called byte. Okay, and it's hard for me to understand what a byte is. So, okay, here is another trick. Typically, in your Unix, whatever you're using Unix, typically there is a buffer of your older commands. And that buffer is set by either you or the system administrator. Typically, it holds 50 or 100 old commands, the commands that you typed before. So when I want to retype a command, I just put the up arrow. If I'm just putting the up arrow and it's recycling, because I think this one probably holds 100 last commands or something. So that's one way of not typing. You can use the up arrow to go through your old commands. So let's say I want something more human readable. So I'm going to put ls minus lh. And look, what it gives me is the size in a human readable format, 5.6 kilobyte. Okay, so that's actually, I can grasp it more. Now, I don't want to type that every time, one part of the program, one aspect of programmer is they are very lazy. I don't want to type every time ls minus lh. I want to type ls, but I want the result to become to 5.6K or 7.0K. So what do I do? Let's say, and that's where the alias come. Okay. So the way that alias, what we can do is like, we can create a new program, a new tool, and we can name it anything. Okay, so let's name it ComBio. So I'm going to create a new tool, and the way to do it is called alias, and I'm going to name this new tool called ComBio. Okay, so I have a new tool, and what the new tool is going to do, and then equals to, and then you put in the inverted comma what the new tool is going to do. So I'm going to put ls minus lh, and then I close that one. So what I'm doing is like, I'm saying, hey, create a new tool or a new alias called ComBio, and it is going to do the job of ls minus lh. Okay, so I created a new tool. So right now, if I write ComBio, look, it's giving me the result for ls minus lh. Okay, so and you can make it as complicated as possible. So let's say I can make it, I'll make it a little bit more complicated. I'm going to say like, okay, how many files do I have? Okay, and and then if I do, it's going to give me like, you have 3 files, or 3 lines, basically. How many lines it gives you? You have 3 lines, and so on. So you can make it more complicated. So that's our first example of pipeline, right? And why is it called pipeline? Because you connect the commands with a pipe. That symbol is called pipe, and you can connect multiple commands with multiple pipes. That's why it's a pipeline. So so let's go back to our alias. I'm going to come back to. Okay.
Dr. Roy.
Yes.
So how is an alias command different from like a variable or something like we call in a script? And
yeah.
how much of commands can you give inside an alias? Like how long can we go with this one?
It can be infinitely long. It doesn't matter.
You just like, okay, so why would somebody use this instead of a script?
Good point. So if you want to do some calculations or something, well, number one is for readability. right? In a script, you can write one line after another line after another line. So it's a very readable. Alias is not readable. After you put 3, 4, 5 pipes, you give it to somebody, they do not know what is it. So readability is a, should keep in mind. Don't make your
Mhm.
program complicated just to make it fancy. Rather keep it readable so that you can come back. So that's one reason for script. There is another reason. This alias is not permanent. That's what I was going to come back to. And in the sense, like if you open another terminal, which I do not know if I can do it here. So let me see. Let me try. The alias is not going to work there, and we'll come back to that part. Let me see.
And if you close this session, like close this terminal and come back, it won't be there.
It won't be there. So alias
Okay,
is temporary.
You do this for something that you're gonna like, say for you're running like, big something, you're constantly using the same commands instead of doing it again and again, you just put it in various. Okay.
Yeah, and I'll show you how to make it a semi-permanent. Okay, and so let me. I do not know if OSC on demand will allow me to open another. Let's try. Okay, cluster. It will let me. It does. Okay, good. So now is the same cluster, right? Look, Amit Roy Wens login 4, same home directory. Okay, in this part, I defined compile. It gives me the result. In this terminal, I write compile. I do not know. Okay, so like the alias doesn't actually transfer from one terminal to another terminal. Okay, forget about giving it to somebody else for yourself. Now, what do you do about it? And that's where our profile file is coming. And that's actually a very important file. We have a chat here. Oh, thanks. Thanks, Ashikut Jaman. And that's where the profile file comes handy. Okay. Let me cancel. Let me just close it by Control D. Yeah. Okay. So now ls, if you type ls minus a, and I'll comment minus a means show me all the files. And you see, if I just put ls, it only shows me 2 files. But if I put ls minus a, it showed me a bunch more files. Why? You see, anytime a file name starts with a dot, the Unix is going to keep it hidden. Okay, it's not going to show that file if you do, because those files has a little bit of special meaning. So either you are supposed to have a dot profile. Sometime dot profile now you have this like bash shrc. And if you are using another kind of shell like K shell, .kshrc, .zshrc, and so on. So let's look into the .bshrc. So here, see, like whoever designed this system administrator is actually a very good system administrator, because he kept a section to say like, put your alias and functions here. Okay, so that's where you are going to put your alias and functions. Okay, and if you do that, then if you can come back and open another terminal, that terminal. Okay, so anytime you have those dot files, I should explain a little bit more. Why the dot file, anything that starts with dot is important, because anytime the Unix opens or even a special program opens, they go and they read that dot files first. Okay, you open a bash shell, is going to read all the .bash files first. You open a .vi, vi that I was using the editor. You don't have to learn vi, that's fine. But anytime I open a vi, is going to read that .vi info first, okay? And that's why these files are special. So now, because these files are, and sometime you'll have a .profile file. And again, that depends on the system administrator where he or she wants those special commands to be. In the OSC, it seems to be .bshrc. So if I write my alias here, anytime I work with a bash shell, it's going to come and read this one first, right? So I can put it, let's put our alias here, alias compile equals to, hold on. Something got stuck. My internet connection is, let's see. Okay, so this one is stuck. You can still hear me though, right?
Yes, sir.
So that
Yeah.
means it's not me, it's the when cluster. So let me open another terminal cluster. Okay. So let's close this part. Leave. Okay. Oh, something is happening. I cannot type here. Can you guys type in? Oh, I know what's happening. Maybe. Hold on.
Yeah, I can type.
Yes, we can.
Okay, I know what is happening. My keyboard was connected to Bluetooth. And then the Bluetooth okay, let's delete it. Okay, so we are back to here. It's not OSC's problem, it's my keyboard's problem. Okay, so I'm going to changing on a read-only file. Why? Let's try it again. Edit anyway.
There is a swap file.
Yeah, okay. So let's, I'm going to write my alias here. Alias comp bio equals to ls minus lh close comp. And I'm going to save this. And in a VI, we'll go through an editor later, maybe during the workshop. Again, as I said, there's an easier editor, but VI is like the traditionally the oldest one, and we are older, so we learned it, and we are stuck with it. They're better editor nowadays. Okay, so right now I have. Let's see if I do. I have combio defined in this terminal. Now let's open another terminal. Okay. Shells. So anytime I opened it, it read the .bshrc file. So if I write combio right now, look, it's giving. Okay, so this is one way, and the strength of alias, actually the strength of Unix system itself, because anytime a program starts, is going to read that dot files first. So you can actually put options into this dot file, and then as you get more comfortable with it, you can customize it in so many different ways. You can decide, like, you know what, I don't like this black background, I want it to be blue. So you put it into some kind of dot file, and it will start as a blue. So but that's like when you get comfortable. But just from your simple things, like you don't have to define the com bio as the new LS. We can define the let's redefine it. Oh, sorry about this. We are here. Let's. Oh, still. I thought I deleted the. file. Let me see. Recover. Okay, so I'm going to redefine ls. So I'm going to alias the ls. So my new function name is called ls now itself. Okay, so this way you can redefine. So anytime after I save this, anytime I write ls in a new terminal, it will give me the result of ls minus lh. Okay, so let's do that. Let's get out of here and open a new terminal. And if I put ls now, look, it's giving me the ls minus lh result. Now you can see, like, whenever I write something on the .bshrc, and then a new terminal reads it. But this terminal, where I just wrote it, it did not read that .bshrc file. The reason is, like, it is only read at the beginning. Okay, so in this terminal, I say like put ls into ls minus lh, but in this terminal it didn't read because it is already running. One way to reread a file is called source. That means, like, whatever in that file, let's reread it. And now it will do it. Okay, so that's the alias part. And I just give you an example for the alias. The reason is, like, where is the alias important? Like, where do I personally use the alias? And I don't have my Linux box with me. What I do is, like, when you are going to SSH to all these different HPC resources, and as you become as you stay in the field longer, you do not only work with a single HPC resource like OS. You will work with multiple HPC resources. And it's a pain to remember what is the login for this, what is the login for that, and so on. So one example that I do is basically what I do is, like, oh man, this is hold on.
Actually, you should delete the swap file.
Yeah, software.
Yeah.
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 I thought there is an option for deleting. Okay. So one way that I usually use the alias is, like, I put, like, let's say I'm going to put OSC. Let's make another one. And you can put as many alias. I'm going to write OSC. Anytime I do OSC, it is going to do me SSH, sex. I don't know what is the is it like ONs, right? Something like this, or
ons.osc.edu.
ons.osc.edu. So you can write these. So what it will do is, like, next time, once you write in your profile, next time you don't have to write, you don't have to remember all these things. You say, like, I saw how to log into OSC. I'm just going to type OSC and it's going to take me to the OSC. And that's how I personally use. Other people may use a little bit different, but that's the strength of Unix, in the sense, like, now you can combine things one way and then put that in a semi-permanent. And I'll come back why I'm calling it semi-permanent, okay? So that you can use it again and again. So now I'm calling it semi-permanent. Why? Okay. So, and that's the next part of it, of an Unix program, is called, what I mentioned before, is the permission. The difference between a program and these scripts is, like, the programs that you use in Unix, like you'll use VMD, I don't know, whatever, like bowtie. I don't know if bowtie is a command line, though. Whatever you use is the difference in the permission. And we'll go through the permission. What does the permission mean? And that's actually very important, because when you want to share files with others, you have to make sure you do the permission right. Okay. So if I do ls minus a, look, I have all these things. And then at the beginning of these, there's this weird letters, okay? D, R, W, X, dash, 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 and so on. What does it mean? So you actually have a very specific meaning. Anything that starts with a D means it's a directory. Okay, simple. It starts with a dash means it's a file. So these are the two files. It starts with the first one is dash. That means these are files. There are certain directories. Why don't we make a directory so that looks, I'll make a directory called temp. So what is our temp? Look, temp is a directory, okay? So anything that starts with the D is a directory, anything starts with the dash is a file. That's a simple part. Then you'll have a 9 character. So 9 character means there are like 3 different groups, no, not group, 3 different category in the permission. Number 1 is your self permission. Number 2 is your group permission. And number 3 is permission for everybody, okay? And if you are using your own Unix machine, then you don't have to worry about groups, because the groups concept only comes into cluster where multiple people works together. In that, if you're working on your own laptop, then you are usually the first 3 letters and the last 3 letters are the useful one. The middle one will most probably all will be dash, 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 or it doesn't mean anything. But if you're working in a cluster, in that cluster, then you'll have 3 different options. Okay, so let's say if I type groups, it will tell me which groups I belong to. And all of you are probably belong to this group, PGS 02999. So now, so we have our own, we all belongs to a group, and then something for everybody. And what do I mean by that? So let's look into this one. So the next letters are always going to repeat as RWX, RWX, RWX. So R means, so first 3 is for your own. So that means you can read this file, R, you can write this file, W, or you can execute this file, X, okay? And then next 3 again, it should be RWX. If there's something is missing, that means that person can, so next is for the group. So in this case, so this is actually a directory. So I can read that directory, I can write into that directory, and if the directory has something executable, I can execute it. And now for the group, you can see is R-X. So that means like anybody falls into this group, that means all of us, we can read it, we can execute it, but we cannot write it. Okay, so what it means, like somebody, well, okay, tell me another person's username. What's your username, Shishir?
It's Shishir PHY, SHIR PHY.
Okay, so if I want to look into Shishir's directory, okay, so let's look at it. Shishir's directory, it should be HISSH. Shishir PHY. Okay, I don't even have permission to look at Shishir's directory. Okay, that means like if I go at one above this, he probably does not even have the read permission given to us. So read, and then you cannot give write, and then last one is for everybody. So that means like everybody who can get into my directory. So first you have to get into my directory. Like I cannot even get into Shishir's directory right now. So if I could have gone to Shishir's directory, I could have read and execute this directory, and everybody could have done that too. So remember, there are 3 different level. Now, whenever you, and that's where the difference between the binary directory and so on, whenever you write a script, your permissions are mostly typically read and write. You can't even execute that script. So if I want to, like, actually, this is an executable. It's not going to do much. Why don't you put it to do something? Okay, let's going to put it. Let's we're going to. No, this is only showing. This is an odd way of showing. Okay, so we are going to. It's going to show a bunch of stuff. Yeah, it's going to do a bunch of stuff. I don't have that file. I'm going to comment that one out. I think that should be okay. So this actually does a bunch of stuff, this one. Okay, so now if I want to run this file, okay, and the way to run it is like, remember, dot means like right here. So get the file right here. And it will be clear why it is like we do that. We'll come to that. So and it says like permission denied. The reason is, if you look into this file, even so remember the first one is for directory or file, then the next three is for me. Even I do not have, let's get it a clear way. Okay, so even I do not have execution permission for it. So that's why you say, nope, I'm not going to let you run this thing. Forget about others, even I don't have it. And if I change it, and we'll come to it, how to change it. If I change it to an executive, give execution permission, then it will let me run. And if I change it for others, then others can run it too. Now let's go to the binary directory. Let's go to the binary directory. This is all our programs are. Oh no, we should go there. This is all our programs are here, right? So why don't we do ls minus lh, and we are going to do one page at a time. Okay, so you see XXXXX, everybody has execution right. Okay, so these are files. L means link. Link means like you point to another file. So whoever the owner has read-write execution, the group has read and execution, everybody has read and execution. So you are only supposed to put files that are under the binary. Actually, you should not put anything under the binary directory. But anyway, whoever puts there, you have to make sure that everybody has the execution right. The reason is whenever you type a command in Unix, again, a command means like a tool. The Unix is first going to look under the /binary directory. Next is going to look at the /user/binary directory. Those are the two spots that is going to look. And if there is a program there, it's going to run. If it cannot find the program, then it's not going to run. Okay. So anything you put there, you have to make sure. So anytime you write a script, even for yourself, or if you want to share it with others, and we'll show you how to share it with others, you make sure that you change the permission with execution. If you do not have an execution permission, if file, nobody can run it. Okay, and we'll go through that. Okay, so anytime you type a command, the Unix is going to go into the binary directory. There's another place it goes next, which is /user/binary. So the binary directory is the fundamental commands of Unix. /user/binary directory is where you wanted I don't know, VMD, you wanted some molecular dynamics software, you wanted something. That's where it will be. Or if you write a program and you want everybody to use it, that's where it will be. So if I go, there'll be so many programs here. But again, if you look at it, everybody has an execution right. So So coming back to Aishwarya's question, the reason I was saying alias is a semi-permanent because you can put it in your profile so that you can use it again and again and again, but others cannot use it. And again, alias is not a good way to write a script, but it's an easy way. But let's say if you write a script and you want everybody to use it, then you should fix the permissions, and which you'll go through. And then in the program, if the tools is good, you probably should keep it under slash in the directory slash user slash binary. Okay, so if you put in that directory, then everybody can use it because anybody, whenever you type a command, Unix is going to first look at under the slash binary directory or under slash user slash binary directory. Okay, so we are going to go to next. We're going to go how to change permission. But before that, why don't I take a little break and see if anybody has any question and anything. And and these are don't worry about writing a script. You'll do Google search, you'll be able to write a script. Don't worry about it. You'll pick it up. The more you use it, even if I tell you how to write a script, if you don't practice, you'll forget it next day. It decays exponentially. What I want you to take it from is like, understand the Unix system so that you know what's going on. And then you have to write a script. Somebody has written that script, some version. Take that, change it, as you want. Okay, any question? Okay, no question. Well, that's good. I can go to bed early. We will see, we'll check, we'll play with this permission thing a little bit. And then finally, maybe we can all write a little script together and that will touch the different aspects of Unix. And then, as you practice more, you'll get efficient in it. So again, this command, you don't have to remember. I don't even remember that. I have to look it up. Okay, but let's see. Hopefully we can do it. So I'm going to change the permission of this file, the first file. It's a script, and right now, and the reason I have to write that because webinar, I have to write this way. The reason is like anytime I type a command, Unix is only going to look slash binary or slash user slash bin. That's the only places it's going to look for that command, for that tool. By putting it in this way, I'm forcing it, I'm telling it, nope, I have another script in my directory. So dot means here the directory, dot slash, here the directory. In this directory, look for the script. So that's why I'm writing it. If this script was in slash user slash binary directory, I didn't have to put the first two character. Okay. So I'm just forcing the Unix to look for a script in my directory. And it says permission denied. So the way that permission changes, so chmod, okay, so change, I don't know what mod stands for, module maybe, I don't know. Something, change something related to mod, okay. And I'm
maybe
going to
modify.
Change, modify, okay, yeah, something. So again, we have three different groups, right? User, groups, and everybody, all, okay? So I'm going to give myself user, you, and I'm going to, it already has the read and write permission, right? It already has the read and write permission. Okay. I want to add the permission of execution. So class. So user group, add a permission, and execution is execution. Again, you don't have to remember this. Just get the idea. And then I give the file name, which one I have to. If I do just this, well, why don't you look at the manual for, this will be a good thing to look at it. So file mode, change mode, cell mode. That's where the change mode comes from.
Mode.
Yeah. So ch mode, square bracket, that means these I don't have to give. But then something comes here that is not in the square bracket. That means like what kind of mode I want to change it. So I have to at least give one option, the mode. If I want to give multiple options, I can give. So ch mode, you need to give a mode option and you need to give a file option, file name. Okay, so these are the three you have to supply. If you do not supply these three, then the program is not going to run. But you have other options to supply anything within the square bracket. Okay, so we're going to try ch mode, change something to the executor. And if I only do this, it's not going to do anything. So I have to give the file name, webinar. So now if I look at it, you see this permission now has RWX. It did not have RW. It did not have X before. So I gave myself to permission to execute this file. So now let's execute this file. And it did a bunch of stuff. It is probably going through a lot of manual, but it did a bunch of stuff. Now, if I look at my directory, you can see, well, it probably cleaned up and did something and so on. But so that's how you, whenever you, even if you write a script, and we'll write a script, a simple script now, even if you write a script, you have to change the permission, at least for yourself. And then if you give the permission for the group to execute it, then the group can run it. If you give the permission to everybody to execute, then everybody can run it. Okay. Okay. Before we go practice a little bit of script, any question? Well, maybe, are you guys enjoying it? Because all I hear is like quiet.
There is another option. You can change the ownership of the file script, because the first bit of the permission, first part, is actually for the owner of the script. So if I copy these scripts to another, if I send it to another user, then the owner will still be me, and he won't be have enough permission. So then he need to be change the ownership, or we can also change the group actually using chown command.
Yeah, so chown is another command that you can change ownership. Okay. So the last few minutes, how much? Yes.
Yeah, so also there is another way to change the file permission, that is to use chmod number. I
Yeah,
just forgot to
it's okay,
mention
Rad.
it.
No, let's not confuse that. That's okay.
Yeah. I just
Yeah,
want to just mention that.
yeah. It's okay.
Okay.
Just keep it simple because they will pick it up. Okay.
Mhm.
So the files that I sent you, if you look into the Unix to directory, there are certain scripts, example scripts that I have given. So we are going to try the hello file first. And I need to transfer that, and maybe, I don't know, one for loop, we can do one for loop or something. So let's transfer that hello.sh file. So upload. And let's see, we can do a for loop too if you have enough time. So I'm going to upload 2 files. So you have all those files in the directory, in the file, in the zip files that I sent you. So let's look at, I have my two more files now, hello.sh and forloop.sh. So let's open the hello.sh. What is in that file? Okay, so it's actually a very simple file. What is it going to do is like, it's just going to print, and the print in Unix is called echo. Echo means like whatever comes after echo in inverted comma, just put that out, okay? And here we'll go through a little bit of, so let's see. First, let's look at the, so, we have the shebang. That means like, I'm telling the computer, whatever I'm writing, you have to interpret it using the tool in the binary directory, the tool called bash in the binary directory. That's your interpreter. And then I have a bunch of comments that I wrote for myself. And then I have anything does not start with an hashtag is a command, is a part of the script. It's a simple script. It's just put hello world. Okay. So let's look at the first permission here. So hello world, hello.sh does not have an execution permission. Okay. And we saw how to change the execution permission. Now, what is the difference between execution permission and not giving an execution permission? Like, it's not that you cannot run a program if it does not have an execution permission, because a program, basically what it is giving in a script. A script, basically what it is giving information to another interpreter. Interpreter means like some kind of basic program like Python, or in this case bash. So again, the first line bash, that's my interpreter. So I'm passing information on this to this interpreter, and that interpreter is in my binary directory. So that means it has the execution permission. So I can run that hello.sh by writing bash. Again, because it's under the binary directory, if I just write it bash, the Unix is going to look there. It's like, oh, there is a bash program there. I'm going to run it. And then I put hello.sh. So what I'm doing it here is like, I'm saying I'm actually running the bash program. And in the bash program, I'm inputting whatever in the hello.sh is. And it's actually doing the work. Hello world is giving me the answer. Now, if I just type hello.sh, it says permission denied. Okay. Now I can change the permission. Again, I give myself execution permission. And now if I run hello.sh, it's going to do hello world. So now you can see what is the difference between a script versus a program. A script, well, I shouldn't say script, input to another program versus making it a program itself. So if I make, maybe a Python script, let's say, I write a bunch of Python commands. So if I want to run it, I have to give something like Python. That means like the command I am running is Python. And then next to it is the parse that I am to pass it to this. But versus if I want to make it a standalone script, I have to tell the computer first, hey, my interpreter is Python. And after that, interpret the following line using Python. So that's basically the difference. Something that you put input as another program, you can make it a script if you tell the computer what interpreter you are going to use. So in this case, my interpreter was bash. And in the first line, I told that. Now let's remove the first line, okay? So I'm not telling the computer, Unix, what is my interpreter. So let's Let's look at the hello.sh. Oops. I'm going to delete the first line. So I'm not telling the computer what is the interpreter. And it's still an executable because I changed the permission. Executable. If I run hello.sh, well, it's a bad example because echo is such a standard program. Yeah.
By default, actually, by default, it's
Yeah.
basic interpreter is Bash. So
Bash. So it's
maybe
not a good.
if it was a Python program, then
Yeah, it's not a good example. But the idea is like the first line you are supposed to tell the interpreter, and then you change the permission, then it's become a standalone script. If you do not put the interpreter at the first line, then you have to use it in a different way, like Python, and then your input. Okay, so let's put back our shebang thing.
by default, if you don't mention any interpreter, it will assume it's Bash.
Bash.
So
Yeah, there was a. Okay, so and then you know there are so yeah, go ahead.
Just a question. So these interpreters are version dependent. Say, for example, you're running a script that's written in Python 3, but what you have installed is Python like an older version. Does that like
It will
like
change, yeah.
because
So
it'll change for everything?
Yeah, so what it will happen is like if a command is similar between Python 3 and Python 2.7, let's say it will run it. But the moment like print command is different between Python 3 and Python 2.7, wherever it faces one of them, and it's like, oh, I don't know what to do. And that's a good example. Like you have to mention the interpreter explicitly. Yeah.
Okay. Thank you.
And then the way that you I think Wilbur talked about module, and we'll touch that more in the sense like when you in your laptop you just install programs, right? Well, I need Python 3.0. I get Python 3.0. I need Python 2.7, and actually you shouldn't do that. You should because then they are going to collide. So the way to do it is one way to do it is module. Another way to do it is like environment. You can create environment. The environment is more for your own laptop, but module is very good when you're using community resources. The reason is you are only given the basic program. Anytime you need a special program, you call module load Python 3.0, module load Python 2.7, and so on. So let's put it, what modules do I have? So if you put module avail, that showed you different modules. So let's look at the Python option. Even like for R, you can see so many versions of R is there. So I'm going to look at, did you miss Python already? Yeah, right here. So when you look at the module, so there is something will be called D. That means like D is for default, I think. So that means like if you don't mention anything, this one will be loaded. Okay, Python 3.6 with Conda 5.2 environment. But let's say you have an older program that runs on Python 2.7, then it's not going to run on Python 3. Okay, so then you have to module load Python 2.7. So let's see, let's give it an example here. So I'm going to module load, and I am not going to mention anything. It's written D next to it, so my assumption is going to load Python 3.6. Module load Python. Okay, so if I do, well, let's just do Python. So you see, it's loaded Python 3.6.6. Okay, so that was the default here, Python 3.6 with a Conda environment. And don't worry about conda right now. Yeah, so that's the default. Now, if I want Python 2.7, let's get out of here. So what I need to do is module load Python 2.7. And you have to follow the same name here. And let's see what happens. So you see what it did? It did not load both the Python. What it did, he says like, I'm going to replace Python 3.6 with Python 2.7 because you cannot have both Python in the same environment. Then you're going to, then programs are not going to run. And so this means like, I'm going to unload this software and I'm going to load this software. So right now I have only one Python 2.7. So if I go Python, and you see like I only have Python 2.7. Okay, so in your laptop, you install different programs, and you go through however installation where you do, either click or command line and so on. It's always good to have, don't just install programs, use conda, because what conda does is like it creates an own environment so that your Python 2.7 does not overlap with Python 3.0 and so on. But at OSC, you just do module load. That means like they have already created this environment where they do not overlap with each other. When you say module, they will install that program and all of its dependency and anything that can interfere with that environment. They're going to unload that program. Okay. So module is a very good way of loading and unloading programs. And again, your interpreter, you have to remember, typically in this case, because this is not a basic program, this is not a basic program, it's a program that you have to load or unload. Typically what you do, you have to write something here, module load 2.7. So then it will know like, I'm going to load the Python 2.7 and subsequent line will be interpreted by Python 2.7. So you have to do something like that in your script. Okay, so let's go through a little program, a script. And for the script, let's look at which script did we transfer here. For loop. Okay, so so again, my interpreter is bash. So the for loop, what it is do is like for means like for I, so a variable will give it an I. You can give it any name, I, J, K, L, doesn't matter. In, that means like whatever the variables had value. And then you can put a number like 1 to 10, and there's this basic, syntax in 1 to 10. But Unix is very powerful. So what I'm doing here is I'm saying like run the command ls. Okay. And if I run the command ls, let's see, I have like 1, 2, 3, 4, 5 options, right? So for each of the option, so first ls will run, it will come back to here. So whatever the ls output, the first option that goes to I. Okay, so if I run this one for I in $ls, so I will have 5 values. The first value is this one. So it will go, and then, so the for structure is for a variable something, then do and done. And inside the do and done, whatever is written, that will be done every time. So for I equal to first value, whatever is written inside the do and done, that will be carried out. For I equals to second value, whatever is written between do and done, it will be carried out, and so on. So another function, and why don't we try that function. The function is called minus f, if minus f. Okay, so is whatever the value of I, is that a file? Minus f means file, and minus d means directory. It's the functionality of Unix. Okay, so let's try this here. Let's write if, let's see what is the syntax. If dash minus f and if minus f. Let's see if it works. I never tried that before. So hello.sh. How does it work? Hold on. Yeah, it may not work.
It should work.
No, it went to the if. Like I wanted to see if minus f. How? Hold on. Let's see. Yeah, yeah, it's not going. Okay, never mind.
Oh, you want to the one line execute
Yeah,
it one line?
I wanted to see if
forget,
hello.sh is a file or not.
just forget the if.
Yeah, just
The
forget
third
the if.
bracket.
Maybe
Yeah.
you can add semicolon after the line.
Let's see. Let's try this. Okay. Sorry, I'm okay. I cannot solve it right now. So let's move on. I'll just explain it. So if it is a file, is going to give an this will return a what is it called, a true value. Let's try one more time. I don't think this will work either.
Actually, I sent you in the chat the comment.
Oh, okay. You did. Okay, let's try that. Thank you.
This one line code.
Okay. So what Shishi sent is says like, well, it's a little complicated too. Okay, so he says like, if this is true, echo
Then
hello, something like, so he's going to echo hello. So what it is showing is like this minus f is going to be true if it is a file, but if I put temp is not a file, temp is a directory, then it's going to return false. And it's not going to print anything. So that's what I'm using here. If this value is true, then do this. So if is another loop. If then phi. Phi means like end of if condition. If this is true, then do whatever between if and phi. So he's going to do if this is true, echo the file name, echo whatever the variable I holds. And then he's going to run it for as many values as I has. Okay, so let's run that. For loop.sh, and it says like, okay, I have for loop.sh is a file, hello.sh is a file, webinar is a file, webinar2 is a file, but temp, it did not do anything because temp returned a negative value. Okay, and this is a little hurried example of how to write script. And the reason I did not go into the details because depending on what you'll be doing during the workshop, you'll be writing different kind of scripts. And at that time, all the details and the nuisances of that script, we can help you with that. Okay, but this is just to give an example of like, there are different kind of what we call loop. That means like, whatever the values ls returns, I want to check each one of them. Okay, whatever the values another command returns, I want to check each one of them. And then that $sign means like whatever the value this program returns, and I will hold that value, and I want to do something with the I. So that's a simple that's a simple script. Now you can put the whole thing in a single line in an alias, like Shishi showed how you can write things in a single line, and you can put that in an alias too. But then it loses readability, in the sense like this is easier to read because things are broken down, versus when you write in a single line, then as the line gets bigger and bigger, it loses readability. So it's better, I'll always encourage you to write script so that somebody can come, or even you can come later and read it easily. Okay, I think I'm going to stop here. I'm going to open if anybody has any question, and then as during the workshop, you'll have to write scripts specific to your program, your work that you are carrying out, and we'll help you with that. Okay, any question?
Should I mention another thing about terminal multiplexer? It's too overwhelming, but
Yeah.
it's very useful in HPC, especially in Bangladesh where internet connection is not that much stable. So
Well,
you lost connection now and then.
Well, you mentioned that during the workshop, you show them hands-on. Anything that's complex right
now,
okay. Yeah, we can show that during the hands-on. Okay. Any other question? Or any difficulties on getting the file or anything? Any comments? Okay, if not, we'll stop it here. And then I'll encourage you to, if you have another question, I'll encourage you to post it in the Slack channel and keep an eye on the Slack channel. Are all of you getting familiar with the Slack channel? Because that's how we are going to communicate during the workshop, share the course materials and so on. So keep an eye on that. And hopefully in 2 days or 3 days, we'll publish the final programming, what we're going to cover and which day. Oisheria, it will be a little late for you attending the lectures. And then, but we'll have a morning session at your time so that you can ask questions. So, and if nothing else, I'll see most of you in Khulna in 5-6 days, right? 5 days. Thank you, Anik. Okay, good night, good day. I'll be in touch.
Then bye.
Thank you.
And thank you, sir,
Thank you.
for your cooperation.
Thanks.